All right, we are determining whether the polygons are similar, and if so, write a similarity statement and give the scale factor. So the first thing that we have to do is really determine, are they similar? And how do you make that determination? Well, the first thing that you need to do is you need to match up the angles and see that the angles are all the same, because if they're not, then it doesn't work. Um, so here we have, I'm going to just use my laser tool. K and Q correspond, right? They're the same measure, so those are going to be the angles that correspond. Angle L and angle R, they have the double angle marks, so they correspond. And of course, we have a right angle here at P and at J. So so far they have the same angles. And in a triangle, of course, if you have a triangle with the same angles, then you know that you're dealing with similarity. Once you get over here to, like, say 15, and you aren't dealing with a triangle anymore, then you can't be insured of that. But we do know for triangles it's true. So now we already know that we've got a similar um, triangle. So we're going to do the one with the angle mark. We're going to say for the big one, K, and actually let's say triangle, triangle K, and we're going to say, okay, is similar to triangle. What's the corresponding vertex on K? Well, K has a single angle mark, and so does Q. So over here we'll have Q. And now, what comes after K? Let's go to the one with two angle marks, L. L, K, L. And what has two angle marks in the small triangle? That's R. And then finally, what's the third vertex for the big triangle is at J with a 90-degree angle. And that's going to also correspond with P on the smaller triangle. So triangle KLJ is similar to triangle QRP. And what is the scale factor? So we can take, if we have information about all the sides, we can take any set of sides. Let's say from K to L. K to L, that's right here, that first two vertices and these first two vertices. K to L is the same as Q to R. And what do you get when you set up that ratio? Well, you get 34 over 17, going from big to small. Okay? And that is equal to, now we're going to go and say, let's do the second and third vertex, L to J and R to P. And what is L to J? L to J is 30, R to P is 15. So we say 30 over 15. And that's equal to, and then let's finally say, let's say the first and the last vertex, those two together that connect wrapping around, you should know that, is KJ, it's this one, 16 over QP on the small one, QP or PQ is 8. And what do they all simplify to? Oh, actually, sorry, you may have caught this, that I wrote 34 and 14, and I should have written 17. My mistake. Sorry about that. That looks like that. That's better, because now what do we have as a scale factor? Well, these all simplify down to 2 over 1 as a scale factor. They all simplify to 2 over 1. And give the scale factor, that is the scale factor. So let me write it like this. Scale factor 2 over 1. You could also write it as 2 to 1 like this, or 2 to 1. Meaning for every 2 units on the large one on the left, there's 1 unit on the right on the small one. Now, first, if we're going to have polygons similar, the first thing we need to do is check that all the angles are congruent, and in this case they are. But in quadrilaterals, that actually doesn't matter. If we could have the same angles, but then like stretch 2 of the sides that are across from each other to have something like this. Like these could also have 90-degree angles, and they're clearly not similar to whatever's up there. So they look closer. Maybe they're okay, but we actually have to go with the numbers. And so let's check out the numbers. Now that we know that they're all similar, we've got to say, how do we set up this ratio? Well, what we want to do is we want to do, like, there's two sides here on this figure. There's the 10 and the 12. And there's two sides on this one, the 8 and the 9. We obviously want to match up the smaller one with the smaller one. So we can say, first write a similarity statement if they are, but we need to check if they are. So what I'm going to do is actually erase those numbers and say, I'm going to mark them with different colors. I'm going to say the small side here of 10 should match up with that smaller side of 8. And here, this larger side of 12 should match up with that larger side of 9. So when we write, like, this is to this, 10 is to 8, as 12 is to 9. Okay, so now how do we know whether these are truly proportionate? We can use the cross products property where we say that multiply the diagonals. 10 times 9 is equal to 8 times 12. Now we actually have to check it. So we multiply 10 times 9 is 90 equals 8 times 12 is 96. And those are not equal. Since they're not equal, then we can actually just stop there. We can state that the polygons are not similar. Okay, so I'm just going to pick a color and box out for number 14, what the similarity statement is that they asked us to write. They asked us to write a similarity statement. We've got that as triangle KLJ is similar to triangle QRP. Put the box around that. And we have a scale factor of 2 to 1. And for number 15, polygons are not similar. We can't go any further than that. That's just the final answer. And that's it. We're done.